the nature of this antigen-antibody response here. Rh negative mother pregnant with an Rh positive son or child, doesn't have to say child, when she gives birth, there's great likelihood that she'll be exposed to some of the child's blood. And in doing so, her body will produce antigens against Rh positive blood. So if she gets pregnant a second time with an Rh positive child, her antibodies will diffuse across the placenta and attack the child's Rh positive blood. So that's the concern there. Type 3 had to do with the antigen-antibody immune complex. And this was a case where you have a lot of antigen and antibody in the circulatory system, and they're forming, instead of big clumps that the macrophage can take big bites of, small little complexes. And so it takes the macrophage a longer time to go and eat a bunch of small little complexes. And so some of these complexes then get deposited in the skin, get deposited in joints and stuff. And once they get deposited there, well, that upsets the cells that are in the area. Cytokines are released, neutrophils get drawn to the area, neutrophils release their cytokines, and the cells in the area get damaged from all these mediators that are being released, all these chemicals that are being released. Type 4, delayed cell-mediated, this was the one that involved the T cell. So all of the three prior to that are B cell or antibody antigen responses. This one here is a T cell response. So delayed response requires a second exposure, just like the IgE-mediated response, the type 1 response. But because it involves a T cell, it's delayed. Your reaction is delayed by several hours, several days even. In this case here, we're talking about poison oak, poison ivy, contact dermatitis, the tuberculosis test that is used. Be sure you know the difference between an autoimmune disease and immunodeficiency. Be sure that you can draw the AIDS virus, all the parts of the AIDS virus. Understand how infection takes place, how the AIDS virus gets into the cell. And that brings us to vaccinations. So what you need to know with this chapter here, a natural acquired immunity versus an artificial acquired immunity, active immunity versus passive immunity. Remember the little box that we put up here? Be sure that you can reproduce that box. Not because I'll ask you to reproduce that box, but if you can reproduce that box, then you have the information to answer the multiple choice and the true-false question. So remember, we had an active and a passive immunity. You had a natural and an artificial immunity. And so natural active immunity was, just exposure to an antigen. Natural exposure that happens every day. Natural passive immunity was antibodies that you get from your mother, okay? Happens when the antibodies pass across diffuse across the placenta, and also during breastfeeding, you can get antibodies. Active artificial immunity, that would be immunization, where we give you a vaccine that causes an active immune response. You produce the antibodies in this case. An artificial passive immunity then is when you are given antibodies. So your body didn't produce them, somebody else did, or an animal did. Be familiar with attenuated vaccines versus inactivated vaccines. Of course, an attenuated vaccine is a live microbe. An inactivated one then is something that's either a whole agent that's been killed or parts of the agent with the antigenic epitope retained. Okay, that's the protein segment that's going to cause the immune response, going to bind to the surface receptors. Know the difference between polyclonal antibodies and monoclonal antibodies. So if I give you if we're trying to produce antibodies, if we expose you to a microbe, that microbe is going to have several different antigenic epitopes, and so you'll get many different antibodies produced. So exposed to a whole microbe, you'll have polyclonal antibody production. To produce monoclonal antibodies, then, you only want one B cell producing antibodies. Much more involved process, as we saw. You have to get B cells fusing with cancer cells, myeloma cells, to produce cells that will continuously produce antibodies. Monoclonal antibodies are a little bit more expensive, a little bit more time. You guys look like you've had enough. So, are there any questions? Yeah, there'll be 4 essay questions. I've touched on each of them tonight that you'll need to know.